Hello, hackers and fellow creative types. David Wilson here for another day of live streaming, live coding of the custom OBS overlay server project. Let me turn this music down a little bit. Last time, we were able to get a WebSocket channel set up between the browser client and the Node.js-based server that we've been writing, and we also were able to get at least an initial fetch of data for the number of concurrent viewers of the stream and also the live chat messages in the stream. So today what we're going to try to do is put those two things together and make a polling backend that is able to load up the data, the live chat messages, and continue to poll them so we get all new messages, and then an eventing channel that allows us to send those new messages as events back to the browser UI so that it could be added to the UI. So the goal mainly is to just get the initial structure set up in place for the eventing channel, and then maybe we'll get the UI set up correctly toward the end, but really the main thing is the eventing channel and the data fetching. One thing I figured that might be interesting to try is to use the Reactive.js, or I guess it's called Reactive Extensions for JS, is Rxjs. This is an observer pattern library. It allows you to set up basically channels of events that you can subscribe to, do transformations to, so that you can have a more event-driven application flow. I figured that would make a lot of sense for this case because all of our logic is based on polling of a data source and then sending information to a UI that's obviously running a separate process. So having this type of channel might make things a little bit more clear to follow rather than having like imperative loops that are doing polling and then pushing information. So we'll do pushing in a different route with this Reactive Extensions library. So let's see if we can get started on that now. So we are basically back in the code where we left off the last time. I haven't had any chance to go and try to convert the API calls to be using the REST API directly yet. I was planning to do that, but didn't have time, unfortunately. So today we'll have to suffer a little bit with the startup time of Node again, but I think it'll be fine. Hopefully, if we're doing things correctly, we won't have to restart too many times because we're basically just trying to see if we can get the live data to be getting pushed back in real time, so we don't have to restart it every time to see new data. All right, so since we want to try using Rxjs, let's just go ahead and add that library. And since I don't know what it's called in npm, we'll pull that up and see if we can find it. So npm Rxjs, let's just try with the most obvious thing first. And if you're here, just say hi in the chat so I can see that you're here and say hello to you. Okay, I think that must be it, Rxjs. So I'll do npm install save Rxjs. And we're gonna have to do a little bit of surgery on the design of the code to be able to get it to a appropriate state for using Rxjs, but that shouldn't be too big of a problem. All right, so let me pull up the docs for this because I've not actually used Rxjs, or if I have used it, I don't remember it. So we'll just go ahead and take a look at the docs to get started. API documentation, if this page works. So let's go to overview, and yes, Black Lives Do Matter. So introduction, this is very small. Let me see if I can bump up the size a little bit. So it explains itself as ReactiveX combines the observer pattern with the iterator pattern and functional programming with collections to fill the need for an ideal way of managing sequences of events. So yeah, basically this is a sort of a functional design pattern, but it turns out to be useful for non-functional programs, mainly just because, event flow, you're dealing with things in terms of a stream of events, and you kind of want to do transformations on those to filter things out or to maybe transform them as they come through. So Rxjs gives you a lot of tools to be able to accomplish that. So let's see, we have a from event that we could import, which is it's an observable. They call that an observable. So basically you can attach to an event like the click handler in a document and then subscribe to that and then log something whenever a click event happens. So in our case, what we're going to try to do is create our own point at which some part of the code can subscribe, and then the producer, so we'll have like a producer consumer pattern. The producer will be the polling loop that's calling the YouTube data API and creating information to be produced, to be pushed into the eventing channel. And then there will be a consumer, which is the subscriber to the events, that will take those events and then send them on the WebSocket channel over to the browser. So what I need to find is, how do we create our own? I mean, I suppose we could have our own event that we create, an event source, I think they call it in JavaScript. Let's see, JavaScript create event. That's probably not the right way to search for that, but let's see. Creating and triggering event, document create event. Okay. So there's dispatch event, event target. Okay. So can you just do that by itself? Let's skip that for now. So observables. So we can create an observable that has a subscriber. Can you push things to the observable? You can only subscribe to it. Pull versus push. Subscribe, subscribe. Let's see. Executing observables. Okay, I think that's probably not what we're looking for. Subjects, maybe that's what we're looking for. Okay, maybe that's a different thing too. Sounds like taps from, I don't even remember the name, CSP. So you have like a subject that can subscribe to multiple things, and then it will pass along those, perhaps. Subscription is an object that represents a disposable resource, usually the execution of an observable. Okay, so observable equals interval. That's interesting. So you can create an interval that is a source for a subscription that can do things. So this could be a way that you could start a polling loop if you were to use Rxjs for everything. So you would start with an interval and then subscribe to that, or filter it to put some transform on it, so that whenever the interval pops, then you do the next thing, which would be to do the polling, and then that produces some result, which they could then have another transformation added to the end of that to convert it to something else or send it somewhere or anything else like that. Let's see. Let me just search for this because the docs are not giving me the answer immediately. So what I want to find is Rxjs. What do they call that in the beginning? So we create an observable. So Rxjs custom observable. I don't know. Let's see what it says. Okay, introduction to the custom Rxjs observable. This is really slow. All right, let's not do that because we might get into trouble again. I should probably be using Firefox for this. Let's just pull it up. Okay, so Rxjs custom observable. Create observable that emits hello world. Okay, maybe that's actually what we're looking for. So oh, come on. We import observable, observable.create. Oh, next. All right, so that's interesting. So you create an observable, and inside the function you pass to it, then you have an access to the first parameter of this function, which is observer. Then you can call next on it, which allows you to feed the subscription pipeline. So that makes sense. Let's see. Let me double check that this audio is not too loud. Okay, so let's try that. What we'll do is just start really simple. We'll try to create an observable and push a couple things to it and then subscribe to it to see if we get the results out of it. I mean, basically like what this example is doing. In fact, let's just be lazy and copy and paste this part of the code. All right, so let's go back to our index file. And I'll just throw it up here at the top. Okay, so get rid of these comments because I don't really need them. Okay, so we have an observable, and we create the observable, then we push 2 values into it, then we say complete. That's important for saying that the stream is done. Okay, so we'll try to run that real fast, and I believe that we should be fine because we've already pulled in Rxjs. All right, little lurkers, let's say hello in the chat here. I see some people that are online, but nobody's talking. It's better if there's a conversation here rather than just me talking, nonstop, because it's kind of boring if it's just me here alone. Let's see. Cannot read property snippet of undefined. Ah, I wonder if... Did I leave a bug in the code the last time? Oh, interesting. So I see that I have concurrent viewers based on the result of this, but it's telling me that, see, line 129. Chat messages, chat response, items. Okay, that's interesting that it's, oh, maybe because there's nothing. So let me just add my own chat message into the chat to try it out. Because maybe this is just an issue with not having any data, and I need to check for that. And let it take its sweet time starting up more time. Okay, so it seems that we are good. And we see we have a hello world here. So it seems that the subscription, the observer, is working as expected. So now that we know how to create a custom observable that can be fed with information, now we need to figure out how we want to organize our program to do polling of the YouTube data API and then push that information into an observable. So since when you create an observable, you pass it a function that then takes an observer as a parameter, we need to find a way to store this observer so that it can be used for polling. And what I think is that we need to have some way to encapsulate the concept of a poller, a data poller. So let's say, for instance, we want to have some component that's able to poll the live chat messages and then produce or to return an observer so that someone could subscribe to that observer and get messages that are coming back as it's being polled. I think that the best way to do this, obviously, in JavaScript or TypeScript is have a class that can encapsulate that behavior. I mean, you could easily go with a plain function that returns an observer that kind of holds all this behavior internally, but I want to make it easy to dispose of things, and I think that the only way I can really do that is if I have some other class that has the state of the polling operation, so I can cancel that whenever it's ongoing. So I think what we'll do is create a class that is able to poll. And since we haven't really been doing very good code organization so far, I might just start in a new file to create the class for that. So let's call this chat poller. And then we can say class, let's export that, export class chat poller. And then constructor, not sure what we'll use in there yet. Maybe what we'll do is create the observer inside of that. We can grab this and then put it inside. And then we'll have a private observer. Yes, let's restart the language server. It crashed for some reason. That was great. Private observer. And I'm not sure what the type is. I'm going to go with observer. I think that's what we saw before, observer. And then let's see if the language server can pick up what we need to import for that. Okay, maybe not. Let's jump back to the other file and just grab that import. Okay, so, oh, observable is what we want. Observable. No, that's actually not right either. So in this case, what does create have? If the language server is going to cooperate with us now. Okay. Let's restart. LSP restart workspace. Okay, let's see if it works this time. Interesting. Okay, let's look at. You know, I wonder if it has typings with it. It may not actually have typings. Process TSL is not running. It must be crashing, but you know, let's just not worry about that right now. I'm gonna bet. You know, we'll just jump right into the node modules and see what we can find. Rxjs. Is there a types folder? No. Observable. D.ts. Do we have any top level thing? Okay, observer.d.ts. So that sounds about right. Oh, interesting. Rxjs compat. That seems weird. Rx. Okay, so that's like another dependency. Is there node modules here? Nope. Rxjs. Wow. And we are having some major issues with the language server this morning. Okay, let's see. Observer.js. It's interesting that this doesn't have anything in it. Observable. Observer. No. That's really strange. Where's all this coming from? Okay. Well, let's just let the TypeScript compiler tell us then, because we are losing visibility into what we can do here. Okay, so I'm gonna just assume this is called observer because we saw something that looks like it is called observer in the types. We'll pull observer here. Did I set up anything weird in my tsconfig? Index.ts. Let's also say chatpolar.ts. That's probably not even helpful anyway. We're trying to use that files section to make it to make the compilation faster, but it didn't seem to work, so it may not even be necessary to hold that there. So now we will say observer, and then instead of pushing the stuff in, we're going to say observer equals observer. But oh, this, yes, this, sorry. This.observer equals observer. And hello, we want to have that as the public observable so that we can get to it from the outside. I mean, this is not necessarily the best way to do that. Like have a property or something would be better, I would say, but we'll just go with this for now. So this.observable. So what happens is that this will allow us to create a chat poller that exposes an observable that can be used for subscriptions. So you can subscribe to the polling operation, and then internally the chat poller will do the job of polling the YouTube data API and then pushing things into the observer. So since we need to do API requests here, we'll probably need to pass in the YouTube client. So import chat poller from chat poller. And let's move these around a little bit because we don't need to have those up there anymore. So YouTube. Let's find where we have the client set up. So YouTube.livechatMessages. We have an instance of the YouTube API here. Where is it? There it is. Okay, const YouTube. So we can create a chat poller instance here. Chat poller equals new chat poller. And then we'll pass it YouTube. And I wish that the language server was running so we could see this, but let me try it again, actually. Restart workspace. No active servers. Let's start it then. Okay, are we happy now? Are we getting any information? Chat, polar, dot. Okay. Still not fully working, it seems. I wonder if it's just having trouble starting up. Okay. So, that's really weird. I would expect that I would get some kind of information here, but it's just not doing it. Oh, now we got something. Great. So what do you not like? Oh, okay. So we need observer of T. Cool. So what we can do now is create a type, export type chat message. We'll just have our own chat message type. I believe this is a way to do it. And then we can say message string, sender string, and then yeah. So we'll say chat message here. So we're creating an observer for a particular type of object, which would be chat message, and then observable of chat message. Okay, so I think we're happy now. And then this create is deprecated, so that's interesting. Let's see what we have in the IntelliSense. Create. Okay, so you say it's deprecated, but you don't tell me what to use instead. That's really nice. Use new observable instead. Thank you. New observable. And there is a... interesting. So now we need to check what the API is for this, because obviously this page that we found is out of date. So Rxjs documentation. All right, so overview. Actually, let's go to reference. Let's get the constructor information. Observer. Okay, let's use a little filter function here. Observer. There we go. So that's just an interface. We need a class implementations. Subscriber is an implementation? Okay, we're missing something for sure. Observables, observer. Consumer of values delivered by an observable. Yeah, I think they must have changed the way this works since that article that I saw, so that's a little bit unfortunate. Subscriber. Oh, okay. All right, I see now. That's my mistake. So then what we do is create a new observable, and then we have subscriber as the first parameter to that function that gets passed in, and then subscriber is what we're sending values to. So let's call this subscriber. That explains why we were seeing weird deprecation stuff inside of the typing files. So we say subscriber. Probably because I haven't pulled it in here yet. So subscriber. And probably it's also generic on the value type as well. Implements the observer interface, extends the subscription class. Well, actually, maybe it is supposed to be just observer. So let's just go with that for now and see if that actually works. So new observable, we're going to do the same thing as we've been doing here. We're just going to say observer, and then this.observer equals observer. So what is this type? Subscriber of chat message. Okay, so it's right after all. Subscriber. Okay. Subscriber. And then we'll just remove this. Subscriber. Yeah, let's change his name as well. Oh, you don't like that? What's the deal? Let's give it a chance to rationalize itself. Subscriber does not exist. Subscriber. Well, it does, doesn't it? Did you mean subscribe? No, I did not mean subscribe. Oh. All right. So, one of these little nice things about JavaScript, if you have a function that does not bind the local environment, I guess you could call it, I'm speaking from a scheme perspective, then this is not actually part of the outside environment. We're not capturing the closure, so I actually need to change this to an arrow function so that we can get this to be the correct this, because otherwise it's going to be pulling this from the, I guess that the language server thinks it's pulling it from Observable, so maybe that's why subscriber was something that it expected to see. All right, so this actually ends up being simpler because we just assign the subscriber to our local variable, or our member variable. And now we have our subscriber and our observable. So this allows us to initiate the polling process. So probably what we want to do is have a method for starting the polling operation. So we could say like private get next page. And this will initiate the operation. Also, we want to take the YouTube API as a parameter here, so we can say private YouTube client, and we'll have to pull the type for that because I don't remember what it actually is. So what is this type? YouTube _ v3 YouTube. All right. YouTube _ v3.youtube. And this comes from the from Google APIs, which we actually want to get away from at some point in the near future, so that may have to change. All right. It may be good to abstract that even now, but I'll take care of that a little later whenever we are further along and actually have this thing working. Okay, so now we have YouTube client as a private member of the class that has it passed in. And then get next page can do the request for the chat messages. So we were doing this request here. Chat response equals whatever. So we can move this code to get next page. Or, let's just change that to be called get next messages. And now that we're using an event-driven design, we're not going to be awaiting promises anymore. We're going to use the then function on the promise so that whenever the result comes back from the request, then we can push that into the subscription without like waiting on the result to come back. Get next messages. So I'll take the await off, and then I won't have chat response anymore. I'll say this .youtube client. What I also need to do is bake the auth configuration into the client when I create it, because now we don't want to have to be passing auth around. So here, I believe what I can do is pass an options object to the YouTube client instead, and give auth here, and also version, if I can type correctly today, version of v3. And then I can take auth out of the other instances that I have here. Auth. Okay, let's take that one out. All right, cool. So that will allow us to not have auth here. And so now the one thing we need that we don't have at the moment is the live chat ID, because we need a way to index the live chat. So we'll also have a private live chat ID, which is, I'm guessing, a string. Would have to be a string, and it's probably not available here. So I will say this .live chat ID, and then we'll have to do then, and then response. Just say R. Okay, so then in the response, we'll be grabbing the chat message information. And since we're doing this in an invented fashion, we're not going to return, well, ideally we wouldn't return all the messages at once. However, it may make sense from a performance perspective not to just like shoot every single one individually, but from a stream management perspective, or a, let's say, data stream management perspective, it makes sense to do them individually so that you can do transformations on them before they go to the end result, the browser client or whatever. So we'll just do them as individual messages because it's easier that way, or it gives us more flexibility that way. Let's just say that. So we have chat response. I think we're going to call that R. And I wonder if we have proper typing here. Great. I think that the types are working. Cool. All right. So chat messages equals r.data.items. And then for each of those, for const message of chat messages, we will be able to say subscriber.next. And since this is of type chat message, we can say message and then pull this information from message.snippet.text message details .message text. And as far as getting the sender is concerned, I'm not exactly sure if they give the name of the sender of the message, or if it's something I have to look up with a separate API call. I'm prepared to do that if I have to do that, so we'll look into it. So we'll just say person here for now, and I think that actually would work, but that only just does the first call. What we don't do here is initiate the next call, but we'll wait for that and do that in a second. So what we want to do in the constructor, well, so I guess the question now becomes, how do we initiate the polling for the chat messages? I mean, the most obvious thing you could do is just initiate polling in the constructor, since we have everything we need in the constructor. But personally, I don't like that because it gives you less control over when things start happening. You're coupling the creation of an object with another operation, which is starting the polling process. So what I'm going to do is have a separate function that will allow the user of this class to initiate polling. So let's go on and create, I don't know if I need to say public in TypeScript, but we'll see. Public, start polling. And we won't give any parameters of that for now because we don't really know what options we'll need. So we could even pass in the live chat ID here, but the assumption is that an instance of a chat poller only cares about one live chat session. So this is something that would not change over the life of the chat poller, or that you would not have multiple instances of polling happening within the same chat poller. So it makes sense to have that to be a constructor parameter. All right, so in start polling, I think we just call this get next messages, and we would expect that when we call that, then get next messages, whenever it gets the result back, it would initiate the next call after some delay. I believe that the live chat messages API gives us that delay so that we are able to know how long YouTube wants us to wait until we make the next request for messages. So we will do that in a moment. But let's just see if we can get the first set of messages coming through the subscriber. Okay, I think we have what we need here. Maybe we can log the message information as it comes through, just so we can see if something's happening. So console.log message, just for our own sanity, for debugging purposes. So we can say message here. All right. And now let's go over to index and create an instance of this. So now that we have the live chat ID, instead of calling list here, I think we created an instance earlier. So chat poller, did I? Yeah, okay. So we're gonna move this down. Did I delete anything? Okay. We're gonna move this down, oops, to this point. Chat poller, and then we also need to pass in the live chat ID, so we'll pull this. Also, there's a possibility this could be null, so I'll probably have to do a check on that before we start it up. Well, the compiler does not seem to be complaining. All right, so we created chat poller, and now we're going to say chat poller.start polling. And to see that things are working, let's say chat poller dot observable, I think it is observable dot subscribe. Well, they have this nifty for each function. I believe what that does is each time something comes through the observable, then it would just call this function. So we can just say m and then console.log received and just type out, write out m. So now this is also another benefit of having the initiation of polling be in a separate function than the constructor, is that we can subscribe to the observable stream and get everything set up before we start polling, so that everything's ready to go whenever polling is initiated. All right, so I think at this point we have enough things set up that this might work. So let's run it and see what happens. Hello, folks in the chat. I don't see anybody talking, so if you're there, please send a message so we can say hello. Let's see what happens now. All right, we have an error, probably a compile issue. Oh, all right, so this is an index.ts. I see. So I have some old stuff left over from the sample that I copied from the Rxjs docs. So we'll try that again. Hello, Bashkam in programming. Welcome. Since we're testing live chat messages, it's helpful to have some live chat messages to see. Hello, ZP. All right, cool. I believe that we have our first received message through the channel. That was easier than expected. All right, so the message output is coming from the chat poller. So we're writing out message here. And then once we see message, we also see received, which is coming from the subscriber at the bottom of here. So yeah, it seems that our observable is working just fine. So now that we have that, we can get rid of the message. And let's see what we can do about getting some polling started. So live chat, let's see, YouTube, live chat, message, API. Okay, cool, we already have that in the history. So we have this, so when you make your first request to retrieve chat messages, the API returns some or all of the chat history depending on the length of that history. Messages in that response are ordered from oldest to newest. Then you also get a next page token, which is basically a token that you can send to the next request to say, get me the rest of the messages after this. And also a polling interval millis property that says how long we should wait before requesting it again. And you definitely want to follow that rule, because otherwise you might hit rate limiting on the API and then none of your API calls will work anymore. So it's best that we actually adhere to this. And we can do that pretty easily by using like set interval or maybe even an observer of some sort to set the delay before we request again. So I believe that all we need to do is just use these parameters or these properties from the response. And I think that they are in the response. Let me just type this out, response, so that it's easier for us to see what we're doing. Response. Let's see what's in there. Response.data. Polling interval millis. Okay, great. And I think that we want to read this every time we get a response back, because they might have different intervals that they want us to follow depending on the activity of the chat, etc. So let's do that. So const delay until next. And we'll say ms so we know what the metric of that is. And then we want the next page token. Response.data.next page token. And I think these things could be undefined. Oh no, they're coming back straight up as okay. So they're not optional, which is great. Okay, so we have next page token and we have delay until next. So we can say set interval Actually, here's what we'll do. Get next messages, since it's a private method, we can add an optional parameter, which is the next page token to use this time. So let's say page token of type string. And then this is going to be optional. So let me just make that optional. All right. And then whenever it's passed, we will use that in the request. So in fact, I think if we even do this next, let's see. Whoa, no. What's the page token parameter? Okay, page token. Nope, wrong. That's the wrong place to do that. It's here. Page token. Right. Okay, so page token, and we're going to pass in, oh, page token. Great, I already called it that. So now we're passing that in if it's there. And then we have the next page token that comes back from the response. And then at this point, we can say set interval. And what is the function for that? Okay, anything. So we can just have an empty, let's see, delay until next ms. You know, I'm going to add, so with the delay that they tell us that we should use, I'm going to add a little bit extra just in case. So let's just add another 150 milliseconds or something like that. I believe set interval is in milliseconds. Yeah, ms as a parameter, I believe that does mean milliseconds. So amount of time the client should wait, and what type is it? It's a number. Great. Okay, so in this case, we'll call this dot get next messages, and we will give it the next page token. And in fact, we don't even need to create the well, actually, let's see. Is it possible that could be nothing? Yeah, so I don't know, just out of safety's sake, let's say if next page token. This may not be necessary, but we'll see what happens. I would think they would have to give us some token anyway. Hey, Alex, nice to see you, dude. They would have to give us some token because what you want is to say, for every request, don't give me everything from before because I've already seen it. Just give me what might be coming next, and what might be coming next could be an empty list because there may be no new messages since the last time you made the request. So I think that they would probably give us a token every time. We'll validate that by just printing it out every time we get it. So let's say console.log next token, next page token. All right, and then set interval, get next messages, and we're gonna say next page token here. All right, that should allow us to poll. So let's, you know, in fact, I'm also gonna write out the millis. I'm interested to see what kind of delays that they are requesting for these. And then I can just do a console.log and say polling, just so that we see it happening. All right, cool. So let's go on and start that again. So if this works and we're able to start polling for new messages, then whenever it's polling and anyone sends a message in the chat, we should see it show up in the output as time goes on, if we're doing things correctly. So hopefully that will be the case. And once we have that, then we can start to restructure our index.ts to, all right, interesting. We see the polling is actually happening. Wow, okay, I think something wrong is happening here. Oh, okay, I made a huge mistake. So set interval, whenever you call set interval, you have to stop the interval, clear the interval whenever you finish whatever you were doing. So what we need to do is, there is a response of set interval, and we need to use that response to cancel it. So let's say const interval equals set interval, and we want to kill it before we poll again. So I think it's clear interval. Clear interval, there it is. Yes, that's not a good thing whenever you start doing polling for every time you've polled before every time. So clear interval, interval, and we can just call it poll interval. And if we may need to abstract this polling logic into some other abstraction so that we can reuse it in other places, because we're going to be doing polling of other parts of the API also. So we may have to do that at some point. Okay. Let's see here. Let's run this now and see if we poll correctly. So as I was saying, now that we see that it does poll, then we can start restructuring our index.ts file to use this effectively and start sending WebSocket messages back to the browser. And if the browser was set up to be able to take those messages and put them into the UI, then we would see the chat widget be updated in real time. Okay. So now it seems like we are polling correctly. So I'm going to send a message in the chat and see if it shows up. There it is, testing the poller. Cool, so that worked. It was a slight delay, but it's not so bad. I mean, if this is what they're telling us to do for the... oh, that was fast. That was pretty instant from what I saw. So if this is the polling they're telling us to do, then I think that we're in good shape to say that the polling of chat is complete, as they wish for it to be. Okay, so let's then move on to setting up the... Cancel now. Let's set up the index.ts to do things correctly. And here, we can actually... What do we call the WebSocket connection before? Oh, okay. So because we're doing things asynchronously with callbacks, we've set up in the previous stream, we set up a WebSocket server. And whenever someone connects to that server, we get this connection event. So one thing we need to do is whenever connection happens, we need to subscribe to the observer from the chat poller so that these chat messages can then be sent back to the client. So what we need to do is find a way to restructure this code so that we can start everything all at the same time. We can start the Express server to serve requests. We can start the WebSocket server to have the live connection from the browser. And then we can start the chat poller, and then whenever a connection comes in, we can wire everything up. So let's see the best way to do that. So what I might need to do is create a class for the server as a whole so I can start this kind of clean. Yeah, let's try that. So we'll say server.ts. Export class. We'll just call it server for now. I'd like to have a better name for that at some point. And we can allow it to be configured with the HTTP port and the WebSocket port. Maybe those are optional or have default values of 3000 and 3001. We also need those to be private members, I think. Maybe it doesn't matter too much, but we can just do that anyway. All right, so we've got that now. And we can set up the WebSocket. So we can say, have a public method called start server, or just start, I suppose we could call it. And in fact, we probably could even have the port configurations in start server, but we won't worry too much about that for now. So we want WSS. We will have that be a private member. So private WSS, and what was the type for that? We don't have, did I have to import anything for that WebSocket? Okay, cool. All right, so we have WebSocket server. The constructor is not happy. Oh, because I haven't finished this yet. So WebSocket.server, does that work? All right. Yes, Alex asked if I'm refactoring the code into a more maintainable structure. Yeah, I'm trying to make it so that it's not such a web of asynchronous calls and other callbacks as I currently have in the index.ts file. So this.wss.on. All right, so we have all that moved over now. So that allows us to start the WebSocket server. Let's make sure we pull in the right port. We also need to start the Express server. So I'll pull this in. Did I just delete something? Yeah. And this auth key promise stuff we probably don't need anymore. Hopefully not. Well, so that's another part of the complication of this whole thing, is that we have to do authentication, and some things can't proceed until authentication is complete. So we're gonna have to find a way to sequence that effectively. All right, let's pull Express over. All right, so we have Express, and then let's see, where else do we call app? Okay, so we have a callback for authentication. So I think I want auth to be a separate thing. I don't necessarily want to have it in the server, because the server is not authenticating. Technically speaking, the client should be authenticating. The API client should be authenticating, and I want to abstract the API client because we're trying to move away from using the Google TypeScript or Node.js APIs or client API, because it's slow, or at least the loading is slow. So eventually, if I'm able to abstract the client concept out, then I can replace it with just direct REST API calls in the future, and everything should still continue to work the same. We won't do that today, obviously, but that's something I want to do. Hi, Eric's. Nice to see you. Okay, so the next step is to see what else we have here. All right, we do the server startup there. So we need to move this code in, and we need to, let's get rid of port here because we don't need port anymore. What we need is, yeah, what we need is the port number, HTTP port. And what I'm thinking right now is, so if we do have auth set up as a different component, but it needs to set up that route to do the auth callback, then we may need to have some way to pass the server, or like externally allow someone to to register a route, which honestly is not the worst thing in the world. I mean, I think that's a perfectly fair thing to do, is to have like a method here that we could say like add route or something on this object. But it does seem a little bit not so ideal. So we'll think about that as we go. All right, so let's get, now what type is this supposed to be? This returns a server from Express. So we will have an express.server, private HTTP server, express, lowercase express.server. All right, we've got plenty of servers here. And we will save that here. We also need to save app too, I think. This.http server. And the instance of this is probably Express. Yes, okay. So this.app equals Express, and this.app use, and we will say private app is express.express. Okay, and why is this not happy? Namespace E, okay. I think that the language server is choking, because nobody's asking for E. Oh, okay, maybe there's something inside of Express that's causing a problem here. Let me check this real quick. Oh, this.app. Let's see what it actually returns. HTTP.server, and where is HTTP defined? Oh, wow. That's actually a real HTTP server in the Node APIs. Import star as HTTP from HTTP. So this is an HTTP server. Okay. I'm assigning it. Okay, it's never read. Fine. Okay, I think that we have this set up now. So if I go back to the index file, I should be able to set that up, but I want to make sure I set it up in the right place. And since we are gonna, let's just take that out right now until we figure out what we want to do with the authentication part of this. All right, so let's think about this from the perspective of the main application flow. So we have this main function, and what we want to do in main is number one, start the server. And number two, we want to authenticate or set up the client, which implies we need to authenticate. And then number three is start polling live data. So starting the server is fine. There's no problem there. We can do that easily. So we can just set it up here. So const server equals new server. And we need to import that. So import server from server. Okay. And what did I do wrong? Not listed within the file project. Oh, okay. That's actually a helpful message. So I didn't add it to tsconfig. We'll put server.ts here. So hopefully now that will be happy. I may have to restart the server, restart workspace. Okay. I think that should wake back up in a moment. Did it? Let's see. No. LSP. All right, it's giving us issues again. Let's keep going. So we have our server object, and I think we can call server.start. So we're not going to worry about changing the... okay, I think that the language server is taking a long time to start up for the exact same reason that it takes a long time to start the application, because it's trying to digest that Google API library stuff. Okay, so we've created an instance of our server called start on it. And that facilitates the first step of everything. So the next step would be to set up a client. And that's something we had started doing here. So we've got some code that will look to see if we have a cached token. And token refreshing is something we may have to start doing at some point in the near future, but it hasn't been a problem yet, so we'll wait until later for that. But let's see, we have our credential loading, and if we don't have credentials, then we try to authenticate. So this is the trickiest part, because we have to do coordination between the client instantiation and the server endpoint that accepts the callback from the authentication website. So I think the best way to approach this is to on demand register a route with the server, and then at that time create a promise to say, okay, here's the promise that you need to wait on to get back the authentication callback, basically, so that the client, when it starts up, it can do an await on that and then get the information back and then continue. So what we might do, let's just abstract this out into a function here maybe, and then we can move that to a class if we decide that the client needs to be a class. So async authenticate client. And what is the object that this needs? OAuth2 client. So that comes back as OAuth2 client. And what type is that? This is an OAuth2 client. Okay. So OAuth2 client. And we were creating one of those above. And we were generating an authentication URL, so we can move that stuff into the authenticate client function. Okay, so now we'll just return that here. So return OAuth. And I think that seems kind of wrong. It can't be right, because I have a variable and a type with the same name. I mean, maybe TypeScript allows that, but cannot find name OAuth2 client. I believe I'm missing something. Token credentials. Okay, blah, 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 blah. I feel like I am missing something. OAuth2 client.getToken. Okay, I created an instance of that here. Okay, I think that's what's the problem. It's actually called that. Oh, so we create Google OAuth 2. It's called OAuth 2 client. I need to name this something different. OAuth client. Okay, OAuth client. And this comes from within. So I've never referred to this before, so I think what happens is I need to pull this here if it's there. Nope. Is it on Google? Could be on Google.o. You know, let's go to definition on that function because that might be the place where it will tell us what the type is. Type of OAuth 2 client. And OAuth 2 client comes from the Google Auth library. Okay, cool. Good enough. And I'm thinking that once we get rid of the actual Google APIs library, all we still need is just the Google Auth library. We're going to continue to use that because I really don't want to write REST API requests directly to their OAuth endpoint. So we'll keep that little bit. But hopefully it's much smaller than the Google APIs because that thing is just massive. All right, now what are you not happy about? I think I must have done something wrong with the... Oh, yeah. I think I probably just need to call this a function. Async function. Yeah. And then OAuth 2 client. It's not a valid async function return type. Okay, yes, of course. We need promise. All right. So now this is happy, I think. And then generate auth URL does not exist on type of OAuth 2 client. That's because we need to change this to OAuth client. Because we have our instance down that we are using for that. So OAuth client. All right, now we have our auth URL and we're gonna return OAuth client. We'll get rid of the 2 here. Okay, so that starts the authentication process, but it doesn't do everything. So what we need to do is pass an instance of server, I think, so that we can tell the server, hey, I want you to register an endpoint for me temporarily. I'm not necessarily 100% happy with this. I think that maybe there's a little bit of kludginess to it, but it's less kludgy than what we were doing before, so let's go with it for now and see what happens. All right, so we'll say authenticate client, and we're going to await that. And when we get that back, it's going to be an OAuth client. So, actually, no, that's right. Okay, that's what we want to do because we're passing that directly in here. So if I'll say OAuth client, cool. And this part needs to go inside of that function. It actually needs to happen first. We need to check and see if this token file is there, and if it is, we don't have to go through this whole rigmarole of setting up a server, etc. So we're gonna put that there. Yeah, async await is a syntactic construct in modern JavaScript and in TypeScript that allows you to write code that appears to be operating synchronously, but is actually behind the scenes generating code that deals with the .then and .catch functions of a promise. Because otherwise, if you have to do that stuff directly, then you're in callback hell, where you have this like pyramid of callbacks that you have to deal with. Await allows you to just have more linear code that is hiding the complexity of all that callback stuff behind the scenes. All right, so we can see auth key promise as credentials. So what we'll do is put this stuff inside the else bracket because we need to. Whenever we load up the cache token file, we are going to return, let's see, token, I think, yeah, I believe that we were assigning that on auth key resolve. Where was I doing that before? I think there's just a credentials, OAuth client.credentials equals token. Credentials. Ah. Yes, I need to create this outside. In fact, maybe even both of those outside. I was probably wrong about that. Because that is actually what I was doing before, so that makes sense. Okay. Put these outside. And then we're doing the check to see if we have the token file. If it's there, then we use it. If it's not, then we need to initiate that process of registering the endpoint and doing the whole login dance. In fact, I changed my mind again. We don't need the auth URL unless we're actually going to proceed with authentication. So let's move this in here. Okay, so now I think that this is mostly correct. And this is authenticate client. So we're going to pass in the server instance because that's what that needs. And once we have OAuth client back, we can set that into the YouTube client object. Oh, and this doesn't need to be here either because we've already taken care of that. Okay, so this is starting to get a lot simpler, I think. So what I might do for registering routes is to expose app as something on the server object called routes. It's a little bit dirty, but I would say it's better for us to defer to the Express APIs instead of having to write a whole shell or whole abstraction facade for that. You know, that whole idea could change later, but for now we'll just go with that. Routes express.express. There may be some way to just get the routing APIs off of the app object. Yeah, there is a way to do that. I'm not, well, okay. Let's just look for it real fast. Let's see, express routes. I know there's a way to have like composition of routes. So you can create like a route object and then add it to the app. Route paths, app, blah, 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 blah. Router, okay, there we are. So we basically create a router instance, and then we can call the same methods on that as you would call on the app object. So we'll call this router and make it an express.router. And then at the time when we create the app, we can require, yeah, so a router lets you do like a sub route namespace, I guess you could call it, like a under a path, but I think you can still do it under the root slash. We'll see if that actually works. If it doesn't work, then we may have to change tack on that. But what we'll do is this dot, that's interesting. I'll create the router first so that routes can be registered before the server gets started up. That makes a lot of sense. Router equals new express.router. I don't think that needs any parameters. No, okay. But it's not happy. Ah, what? That's a constructor, isn't it? No, it's a function. All right, cool. That's confusing. All right, so we created a router, and we are exposing it publicly. And then what we can do is inside of the authentication client, we can add the endpoint on the router directly. And we were doing that here. So I can take this function that I had, or this route registration that I had put there, and I can add it here. We may have to just run through auth one time to make sure this works, but it feels like a little bit of a waste of time for the nature of this particular stream. So maybe I might wait and do that later. Let's just move the code around just to get it sort of in the way we want it. Server.router.get, and that will allow us to register the OAuth2 callback here. And then we need to rename this because we did rename it before. OAuth2 client, OAuth client.get token. Okay. And instead of doing auth key resolve, well, we may actually need to do a promise here. So auth key resolve, where were we putting that? Okay, so this is better because at least we are encapsulating it inside of a function. It feels less dirty to do it that way. So here what we'll do is create the promise, and then we can manage it internally and not have to worry too much about it. Okay, so we have auth key promise, and we don't use reject. Yeah, I don't really care. I mean, it can squiggle it all at once. All right, so auth key resolve, and we've got that registered, and what we'll do is await that here, await auth key promise. I think we had code for that. I may have already deleted it by now, but so auth key promise returns the token, I think. Token equals await auth key promise. I think that's right. No. String has no properties in common with type credentials. Oh, okay. I think I may have lost some code that I had before. Let me double check that. Okay. Hit the auth URL. So get token, whenever it succeeds, does a get token callback, and token here is of type credentials. So maybe that is what do we say token is? Token is credentials. Okay, that's weird. What do you not like? Await auth key promise. Oh, is that right? Token auth key resolve. It's expecting. Huh. Okay. All right. I think that's the problem, is that we didn't type this correctly to begin with. So this is supposed to be credentials. Okay. I think that gets us where we want to be. Cool. So what this does is abstract the whole authentication process into a single function that's asynchronous and allows us to await the result. So we can call authenticate client and then get our OAuth client instance back that's been fully authenticated either by using the cached token or the full authentication flow. One thing I need to do is, instead of just typing auth URL here, I need to set it up so that we can pop open the user's browser to do the authentication flow, so that's not so bad. But for now, we'll just, or not so much of a pain in the butt. For now, we'll do this. Please go to the following URL and log in. Okay. So that takes care of that. So now let's just go look then at the rest of what we need to do. So step 3 that we wanted to do was start pulling the live data, and that is basically just this process of grabbing the stream details. So we've started doing that here by grabbing the live broadcast. You want to get the current live broadcast and then get the live chat messages as a result of that. So, so one thing we haven't done yet is set up the server for the particular page for feeding the data back into the overlay. And this is what this registration does. And I believe, okay, this is actually useful because this is the point we want to be at for feeding that information into the UI. Okay, so we have the chat puller. We were already writing out the messages that are needed for that. So we don't necessarily need to do the page registration yet. In fact, let me just do the server.router.get so that we at least get the same behavior. Chat message promise. This stuff needs to go away for now. We'll put this back at a later time when we're starting to work on the actual widget UI. For now, we want to just see that the messages are getting propagated back to the browser through the WebSocket channel. So what we can do is we need a way to send a message to the WebSocket client. And we may need the concept of IDs, client IDs, or some way to identify them. Because the idea is that you would probably have multiple browser sources, and even like my own browser open on a different page, like a dashboard page, that all go to the same server. So you'd want to be getting live data that gets updated to all those. So we need to have the ability to manage multiple WebSocket clients at the same time. For now, let's just worry about the single client. And then in another stream, we can deal with multiple clients. So for I could probably have an array of all active clients. So how about that? Let's say private, what is this connection type? WebSocket. Okay, cool. So WS clients could be an array of WebSocket. And then we'll make that an empty array to start with. And here, when we get a connection, we can say this.wsclients.push ws. And then, yeah, we still want to have this message registration. And what does this not like? Does not exist on type server. Do you mean client? No, I don't mean clients. Okay, it's because we're not binding the function. So we will change this to an arrow function to achieve the local class binding. Okay, so now we have wsclients.push. So now we can remove this send. And we can have a message to, let's just say public broadcast. I don't know. We'll just say broadcast message for now to send it to all clients. It's not necessarily what we want to do in the end, but just to make things a little bit faster, let's just do this. So message of type any, because we want it to take any type of message. And then this, let's see, for const client of this.ws clients. We can say client.send, is that right? Send, no? Is that not what I was doing before? Yeah, it was send. I don't know why I didn't pick that up, but also I think that I deleted that already, but I think I was serializing this JSON object at the same time. Send takes any data, so we're going to say json.stringify the message, and then send. I think that's all we need. Yeah, there's an error callback. I'm not going to worry about that right now. So what this will do is allow anyone to call on the server, to allow them to broadcast a message. At some point, we may need to expose an event that allows someone to subscribe to new clients appearing so that you can deal with the client itself and not talk to the server all the time. But that's out of scope because we are running out of time here. But so we have broadcast message. And now that we have that, we can just wire this up like we were doing before. Chat polar dot observable dot for each, and then for each of those we can say server dot broadcast message m. Okay, and then once we start polling, that should start broadcasting. All right, so if this all got wired up correctly and we don't have any major errors, then we might be able to go to the page. Actually, we do need to set this up. Let's put this back, but only send the page that will allow us to connect to the client, because obviously we won't see anything happen in the page unless the WebSocket client is connected. So let's take this chat string bit out. Whoops. Okay, so that should be enough. All right, let's, fingers crossed, hope this works. If it didn't take so long, we would be able to have a faster iteration time here, but it'll get done before next time. Okay, so far, so good. Let's see if I jump over to a browser and pull up localhost 3000. Okay, so it cannot get the root route, and I know why now. The reason why we can't do that is because I never added the router to the app in the server startup. And the documentation for that was app.use. This.app.use. And I think that we have to put it to the root route and say this.router. So this should work. Let's get prepared here. Okay, let's see if we load. All right, something's happening. So let's pull up in the console. It says we're connected. I don't see any messages coming through yet though. So that's interesting. Let's make sure I did this correctly. So we have our chat poller. We're setting up with a live chat ID with the YouTube client. It says we have concurrent viewers, so obviously it's getting data back from the client correctly. The only thing is if, let's see. Oh, no, it works. Thanks, Alex. It's interesting that it didn't actually send all of the originals. Oh. Huh. I wonder if it times out after a while. Like if it hasn't loaded enough messages, or sorry, I think YouTube deletes them. It doesn't hold all the live messages the whole time. So maybe like halfway into the stream, if you ask it again, it just gives you whatever is like the most recent, you know, within the past 5 minutes or something. So I'll try it one more time and just double check. I just sent a message and it should show up here. Yep, double checking the message broadcasting. Okay, cool. So it seems that we are getting live chat updates from the YouTube data API, and it's going through our Rxjs polling logic that allows us to do polling of the API and then pushing the messages through an observer so that the client is able to be updated live based on any new messages that come in. So like you've seen, we just create the chat poller, and then we say for each thing that comes through the observable, we broadcast a message to the server. So obviously this is pretty primitive wiring of this whole setup, but it just validates that we can do this. So maybe in the next stream, what we'll try to do is to get the full end-to-end live chat widget UI displaying on the screen in a mostly reasonable looking way with live messages coming from the chat, so that in this area of the screen, in the top right-hand corner of the screen, we could have the live chat messages overlaid while the stream is going on. I think that should be pretty cool. I think that is enough for today's stream. That was pretty fun. I'm pretty sure I've never used Rxjs before, so it's cool that we were able to get something going so quickly. And I'm glad that the refactoring of the main logic here did not go down in flames. That was lucky. Did the stream go down for a bit, Alex? Alex says it's back, so I wonder if the stream went down briefly. Anyway, thanks everybody for joining today. That was awesome for you that all of you showed up. Looking forward to doing the next stream. I'm thinking that it will be on Wednesday. I know last week I said it would be on Wednesday and I didn't show up, but this week I think that will be much more achievable. So we're going to continue this on Wednesday, and then maybe by the end of the week we'll have something usable that we can use in future streams, and then maybe we can start like thinking about a new project. Just off the top of my head, I think the next thing I might want to do is start talking about Emacs configuration, because I know that there are people who have seen my weird setup and were sort of curious about how to configure Emacs to be a more productive editor and general productivity environment. So I think that maybe next week we might start doing some sessions where we will start building up an Emacs configuration from scratch, so that you can see how to configure this environment for yourself. So that might be pretty fun. But anyway, thanks again, everyone, for joining. Hope that you have a great rest of your day. And as always, happy hacking. See you later.